Now, to say that the potential energy should, that point should be at the minimum potential, we are actually saying that the point will be at stable equilibrium when it is at the point where the potential energy is minimum. This is true in its own and there is no other condition required, but this is not a mathematical form. We are looking for a mathematical form. This is true. Now we'll look for the mathematical condition which will satisfy this. Potential energy should be minimum, because after this, if the potential energy increases, then du by dx is positive, force is negative, it brings it back. After this, again du by dx, if it again increases, then actually du by dx is negative, force is positive, it brings it back. So potential energy to be minimum is a complete condition for stable equilibrium. Now mathematically, to satisfy this, we just now studied a few minutes back that at a point, for the minimum condition, for the point to be at minima, dy by dx should be 0. So the first thing is, if it is at minima, then du by dx should be equal to 0. First thing. Okay. Now we also saw that du by dx is 0 at minima, that's true, but du by dx is also 0 at maxima. So we have to eliminate that condition of maxima. So for minima we saw two conditions. Dy by dx is 0 and d square y by dx square is positive. So clubbing both, if this is minima, then du by dx will be 0 and d square u by dx square will be greater than 0. These two conditions will satisfy that this is at minima. So if we have any expression of potential energy, then we can find du by dx and check if du by dx is 0, and we can also check if the double differentiation of potential is actually greater than 0. If a point satisfies these two conditions, then that point will be a point of minima. Okay, so just to quickly check, I'll just give you one expression and you see. Suppose we have y is equal to x to the power 4 by 4 minus x. I just gave you this one, but still. This is the equation, and just check if x is equal to 0 is a point of maxima. Just check. X is equal to 0 to the point of minima, sorry. See if it is minima. So for minima, first you have to see that du by dx. This should be the expression for potential energy. You just see that du by dx is 0. So find du by dx. Du by dx is equal to x cube minus x. And at x is equal to 0, indeed it is 0. But that is not sufficient. D square u by dx square should also be greater than 0. So d square u by dx square is equal to 3x squared minus 1. And at x, fine. D square u by dx square is this, and at x is equal to 0, it is coming out to be negative. So x is equal to 0 is not a point of minima. Okay, now let's see if x is equal to 1 is a point of minima. Now at x is equal to 1, du by dx is 0. And at x is equal to 1, du by dx is positive. So x is equal to 1 is a point of minima. That's how we'll do it. Okay. So this is the condition for minima. This is for stable equilibrium. Now there could be condition for unstable equilibrium. Like this, at this point.